Hello and welcome to another video on quantitative chemistry, where today we will be answering a question in amount of substance where we are being asked to find out and calculate the minimum mass in grams of magnesium needed to completely reduce 1.2 kilograms of silicon dioxide. Now, these sorts of questions can stump a lot of students, especially because they are very heavily based on calculations, and there is a step-by-step program that you can take in order to reach the end of this question and finally find your answer. The first thing that we're going to do is we're going to look at what the question gives us, okay? We know that the question gives us 1.2 kilograms of silicon dioxide, and it also gives us the atomic masses of each element. Now, the first thing that we're going to do is we're going to have to know which equation we're going to use. And the equation that we're going to use normally in amount of substance is going to be moles equals mass over mR. Moles equals mass over the formula mass. That is how we work out the moles. So mass divided by the mR. Now, we are able to find out the moles of silicon dioxide because we're given the mass, which is 1.2 kilograms. And we're also given the ability to find the MR. The MR is not the same as the atomic mass. The MR is for a molecule, like silicon dioxide. The AR is for the atomic mass for one element. So we need to find the formula mass of silicon dioxide. Now, the way that we're going to be able to find out the formula mass of silicon dioxide is simply by adding up the atomic masses of each element, each atom of each element inside the compound. So for example, for silicon, we can see that we have 28, so that's 28 plus. Now we can see that for oxygen, we have 2 atoms of oxygen. So that means we're going to look at the atomic mass of oxygen, and we can see that it's 16. So we're going to add 16 twice. So that means the mass is 1.2 kilograms, and our formula mass is 60. However, there is one problem, and we're not complete yet to substitute this into the equation. In chemistry, we do not use kilograms. We always convert the kg into grams, and we do that by timesing by 1,000. So we have 1,200 grams instead of 1.2 kg. So now we can add this all into the equation. The moles of silicon dioxide equals the mass, which is 1,200 grams, divided by the formula mass, which we worked out over here, which is 60. Plug that into your calculator and you'll get 20. So I'm just going to write on the side here moles, and I'm going to write 20 for silicon dioxide. Now, the question is asking us to calculate the minimum mass in grams of magnesium. Okay, so the way that we can work out the minimum mass in grams of magnesium is by using the same equation. So now we have to rearrange this equation to make mass the subject, and that is mass equals moles times mR. Okay, mass equals moles times mR. So we need the moles, first of all. And how can we do that? Well, we've already done the first step, which is find out the moles of silicon dioxide. Now it's just a matter of ratio. Now, when a compound doesn't have a number before it, as you can see, magnesium has 2 before it, there's an invisible 1 right before it. Okay, so therefore, these two are in the ratio 2 to 1. So when you go from 1 to 2, you times it by 2. Similarly, when we're trying to find x over here, going from 20 to x, we need to times by 2 because it's in the ratio 2 to 1. So x is going to give us 40 because 20 times 2 equals 40. And that's the moles of magnesium. The moles of magnesium is 40. Now we've worked out the moles, we just need to know the mR of magnesium. We're given that here. The mass of magnesium is 24. And we don't need to work out the MR because magnesium isn't a compound, it's just the element itself. So we can just use the atomic mass, which is 24. So 40 times 24 is going to give us the mass, which plug that into your calculator, 960 grams. And that is your answer and how you work out the minimum mass in grams of magnesium.